In this episode, we will implement a linked list. We will start by writing the implementation of a simple linked list and then modify that implementation to implement a doubly linked list. A linked list is a data structure that represents a collection of elements. Every element is going to hold a value, in this case A, and a reference to the next element. So this will in the end form some sort of chain. The last element of this chain or list doesn't reference any other one, which means that is the last one. So we need to define a list which points to the first element or node, and every node points to the next one. So let's write this into code. First thing we need to do is to define a list, which is a structure which will have a field called head, and this head will point to node, which is the type that we will need to define right now. So let's define a node. As we just saw, the node has a value. Let's just use integers for the values and have a reference to the next one. So let's call that next, which will point to a node. Okay, so the first method we need to define is on the list, we'll call be first, which will give me the first node. So this will return a node. It will be as simple as this, return list.head, right? Also, my list will need to implement a method called push in order to push values. So every time I call push, I add a new node to this list. So I want the value, which I said is going to be an integer, and this is not going to return anything. We are going to implement this later. So now we have all the methods I need on my list. I need to implement some methods on my node. So the first method on my node will be next. So next will return me the next node. In this case, when I call next on my first node, it will return me the second one. So this will probably return node.next, which is very simple. Okay, so I have all the methods I need. I will probably need to implement push. So let's start by creating a new list without any node. What I want to do is when I call push 1, list push 2, and list push 3, what I will be doing will be something like this. I will be push the first element. When I call push again, it will call after the first one. And when I call it again, it will call it after the later. So let's do that. So the first thing is when I push, I need to make sure that my list is not empty, which means that head is not nil. If it's nil, I will assign the first node to my head. So first I need to create my node. Let's create a node with value, the value that I just passed here. And if my list is empty, I will assign this node to the head, which is the first element on the list. And also I will assign this to the tail. And what is tail? Still nothing, but I will define it right here. So tail will point to the last element on the list, or to the last node. So my list has two pointers, or two references, to the first one and to the last one. Every time I push something, I will append it to the last one. But if my list is empty, I will also assign it to the head, right? So the first element is going to be pointed by head and tail. Okay, so for now, this should be working. Let's execute this. Everything is fine, right? Now, if I want to call next on my nodes, so let's say I do list.first, I have my first node here. Let's print the value. Let's see what happens here. This will work. It prints 1. If I change this to 10, it will print 10. But now, if I do n is going to be equal to n.next, which will return me the next element, and I print its value, what happens is that I have a memory problem, because next is not assigned yet, and that should be made in the push method. So what we'll do here is that if my list is not empty, which means that I already have at least one node, I will say this. My current last node dot next is going to be equals to the node. So now this should work. What I just did, let me show you on the picture. So let's assume my list is empty. When I assign a first node, my head and my tail reference are going to be pointing to this element, to the first one, A. Now, when I assign a new one, what I'm doing here is that I'm saying, hey, my tail is pointing to here, which is A element, or the first one. I want that this part of the element, which is next, points to the newly created element. And then I move head to point to this one. So if we go to the code here, this is exactly what I'm doing. I'm creating a node for every case. If my list is empty, I will create this, I will assign this node to the head. In every case, I will assign it to the tail as well, after the if. But if my list has already some element, the tail, the previous tail, dot next is gonna be the node. So this is pretty much what we need for a linked list. Now let's try to traverse this list. We know that the last element dot next is gonna be nil. So let's do a for, which we have learned in the previous section. And let's start by saying n is gonna be the first node. Okay, this is my first node. Let's print the value, and then let's assign it to the new one. So n.next will be this. Now, what happens if this is nil? I shouldn't continue the iteration, I should start. So if n is equal to nil, which means there's no next, I will just break the execution. That's it. I mean, this should iterate until we find a nil element. Okay, so we've print 1, 2, 3. Right? So this is pretty much it for the simple linked list. Now I want to explain you what are doubly linked lists. In doubly linked list, nodes points not only to the next one, but to the previous one. So why is this useful? Because I can go back and forth depending on the operation that I want to do. So let's modify the current code we have in order to implement this. So the first thing we need is that as we want to traverse the list backwards, we need to define a method to get to the last element. So let's define the last method, which also will return a node. The implementation is, as you may guess, return the tail, right? Okay. Also, as we saw in our picture, nodes has a reference to the previous element. So we need to add a new field called pref, which also gonna point to a node, and then a method which returns that. So here's pretty obvious. Now, how to traverse this is gonna be like this. Last, and then I'm gonna copy this because it's pretty much the same, but instead of going to next, we should call previous. Now, there's something missing here because I haven't implemented that yet. So if I run this, I'm going forward, 1, 2, 3, and then it stops in 3. Why? Because the previous element, which is here, it's always empty. So the for loop goes here, and it's always nil because it's empty, and stop the execution. How to do that is right here. So every time we assign a new element to our list, we need to link it back to the node. So the new node dot previous is gonna be equal to the previous tail. Okay? So let's execute this and see what happens. And now it works. I have 1, 2, 3, and then 3, 2, 1. So let me go to the picture again to explain you what we just did. Here, every time I push an item to the list, doubly link that. So I link the new element. Let's say I'm assigning B to the list. As we did previously, we assign B to the first element next reference, but also that element, which is A, it's being assigned to the previous one. So again, B is assigned to A, and A is assigned to B. Okay? So let's just review the code one more time to understand what we just did. The list is empty when we just started. So this will be true. Head is empty. So we assign the node to head, and we also assign it to the tail, which is the first node is going to be pointed by head and tail because our list just have one element. But on further iterations, that tail.next is going to be assigned to the newly created node. And also that node.previous is going to be assigned to the current last one item, so that I can iterate over them. Now, for traverse the list from the beginning, you call L.first, and you do this. For traversing the list backwards, you just call last, and instead of calling next node, you call previous node. Now, this is maybe not very useful in a language like Go, because as we saw in the previous section, we have slices, which is pretty much the same. And also Go offers a list package, which is pretty much what we did first with what we just did, but with other names. They call element instead of node, but they have next and previous. They have a list, and they have other methods which are like for finding elements, getting the size of the element, removing elements, and so on. So probably when we write production code, we're not going to implement our own linked list, but it's pretty good to do this kind of exercises to put in practice what we've been learning. So as an exercise, if you want to improve a little bit, I will say try to implement, and let me write it here, try to implement the find method, which should be, I'm not going to implement, I'm just going to write the signature of the function. It's going to be find, and then value, integer, and this should return a node. So this function should traverse the whole list and return the first node which matches that value, like node.value should be equals to this value. So if you want to improve a little bit, implement that. And of course, if you want to understand how this is implemented in the standard library, you can also go here and let's say I want to see how my element is implemented. I can just come here and go to the code, which is super well documented. This is going to be very useful if you want to improve your skills.